We want to find the arc length of x equals y squared from x equals 0 to 9. So the integral, the formula is going to be from a to b, square root 1 plus, and because we solve for x, it's going to be dx over dy squared dy. And so the graph looks like this, and when x is 9, we get plus or minus 3. So that's going to be the bounds from negative 3 to 3. Now the derivative of x in terms of y is just going to be dy or dx over dy, and the derivative of y squared with respect to y is just 2y. So this just be 2y squared dy, and because this is an even function, we could just take 2 times the integral from 0 to 3, 1 plus 4y squared dy. From here, we want to do a u substitution. Basically, we want the inside to be 1 plus tangent squared. So, we want 1 plus 4y squared to be 1 plus tangent squared. Because 1 plus tangent squared is secant squared, and then take the square root of that as secant. So this means 4y squared is tangent squared. Take the square root of both sides, and we get y is 1/2 tangent. So that's going to be the substitution that we do. So dy is just 1/2 secant squared. But we also want to change the limits. This is in terms of y. So if y is 0, that means tangent also has to be 0. So theta has to be 0. If y is 3, that means tangent is 6, so theta is inverse tangent of 6. That goes up here. And then we have 1 plus 4y squared. So we could just leverage all this work on the right here. That's just 1 plus tangent squared. And then dy will just be 1/2 secant squared. So now we can simplify. One plus tangent squared is secant squared, and then you take the square root of that as secant. And the 1/2 can come outside and cancel with the 2 actually. And then we have secant squared d theta. This is just secant cubed. And in order to integrate this, I'm going to use the reduction formula, which says that the integral of secant to the nth power is secant to the n minus 2 over n minus 1 times tangent x. So tangent x is on the top actually, plus n minus 2 over n minus 1 integral secant n minus 2 dx. So for secant cubed, that's going to be secant 3 minus 2 is 1, so secant x tangent x over 3 minus 1 is 2, plus 3 minus 2 is 1 over 3 minus 1 is 2, integral secant. And for this, you can, in order to solve this step by step, you would just multiply by secant x plus tangent x on the top, make a u substitution, let u equal secant plus tangent. So du would just be secant tangent plus secant squared, which this is the same thing as secant times secant plus tangent, which is exactly the numerator. So it's just du over u, and then that's going to be ln of u, but u we said was secant plus tangent. And then we can evaluate this from 0 to inverse tangent of 6. So the nice thing is, if I plug in 0, all of this stuff becomes 0. So I don't really need to worry about plugging in 0. So what I need to do is plug in 6, or inverse tangent of 6. So I need to find secant of inverse tangent of 6. And then tangent of inverse tangent of 6 is easy. That's just 6. So I don't really need to do anything with that. So on the side here, let's try to solve for secant inverse tangent of 6. Now, we're going to call this theta. That's our angle. So we have secant theta, in other words. And if theta is equal to inverse tangent of 6, that means tangent theta is equal to 6. We can think of that as 6 over 1, which tangent is just opposite over adjacent, and then Pythagorean theorem says this is root 37. So if I want to find secant theta, that's going to be the hypotenuse over adjacent, which is root 37. So let's use that fact. So it's root 37 times 6 over 2 plus 1/2 ln root 37 plus 6. Now, the 6 and the 2 are going to cancel, so we're going to get 3 root 37 plus 1/2 ln. And here we don't need the absolute value anymore because root 37 plus 6 is obviously positive, so we don't need to worry about that. So this will be the final answer.